Now, a semiconductor is in between. It's basically a resistor. So it's not going to be void of resistance, but it's not going to be the perfect insulator. So it's going to be somewhere in between. What factor determines if a material makes a suitable semiconductor? Okay, there it is. That's the answer. What unit of measure describes resistance? Ohms.
I don't know, and see, I don't need to get it to
Show it's 1, 2, 3, 4, whatever in engineering notation. So it's going to be 10 to the third, 10 to the 6th, 10 to the 9th, 10 to the 12th, or negative. In this case, it's positive. We've seen this. Engineering notation is similar to scientific notation, except the engineering notation can have 1 to 3 digits to the left of the decimal place. You got to remember that. I want 1 to 3 digits to the left of the decimal. So you will have a number between 1 and 999. And the powers are 10 or multiples of 3. Engineering notation, I think we got it by now. We did this one early on, and I guess it's a good refresher. Are the following values expressed in proper engineering notations? How about the first one? 2.4 times 10 to the third.
Yes.
Yes. Because there is a 1 non-zero digit to the left. So I do have the number 2 to the left of the decimal, and the coefficient and the notation allows between 1 and 3 digits. Okay. So we're 2.4 times 10 to the third. It meets all the criteria.
Yes.
Yeah.
The next one, yes, because there are 3 non-zero digits to the left of the decimal point. So we've got 100 over there. And the notation shows between 1 and 3 digits in that location. It's a 6.
So how many can you have with the right?
So you can have as many as you want, but generally two or 3. I don't know that
If you go 3, then you could just go another, oh wait.
Well, no, it depends on where the decimal is. Generally, we go. I don't think you'll see anything that I give you that's 2 places beyond the decimal to pass the decimal to the right of. Okay, negative 4.5 times 10 to the 6th.
Yes.
Yes, there's 1 non-zero digit to the left of the decimal point.
No.
No and no.
And it's 10 to the 6th. So no and no. Okay, because you got a 0 to the left of the decimal, and the other one has too many digits to the left of the decimal. Okay, show. I think that's probably on the test.
Pico.
Yeah, that's 1 picoamp.
You show me that number again. 0.0.
Should be 9.
There's 9 of them?
I wanted, yeah.
What's Pico? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 11 of them.
Oh, then that's great.
Wait a minute. 1,
Yeah, no,
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so it's 1 pico, right?
Yeah, picoamp.
How do you write pico?
1 PA.
Where's your output?
Okay, and then I had some examples to go through again for metric notation. 0.0025 volts is 2.5 millivolts. Again, in metric notation, I want to see between 1 and 999 to the left of the decimal. So 3 millions microvolts. That's microvolts. Okay, so that's 0.00375 kilovolts. Yeah, so I went to microvolts, kilovolts. I won't do this to you.
Why?
You'll either go from the base to the nano or the pico, or from the nano or the pico back to the base. 10 kilowatts is the kilo K is 1,000, so it's 20,000 watts. There's a point, whatever amps, so we go milliamps. 456. So the goal is to have between 1 and 3 digits to the left of the decimal, just like scientific, just like metric notation, or engineering. There's a whole bunch of ohms there, so that's going to be to megohms, 0.36. That one doesn't have anything to the left of the decimal. These were examples I pulled off the internet. can't say, that's probably not the choice. Oh, no, that's because it asked, it specifically asked for megohms, that's why it's a
Yeah.
decimal.
So are we just doing conversion?
Yeah, I'm gonna just go take you for in and out of the base. You know, from whatever the straight ohms or watts, either into metric notation or out of. So those may not really, the last one's probably more from millivolts, megavolts. The capital M is mega. I haven't seen any mega in the tests. Okay, so what is the color code for a particular resistor, 10%? What is the value and tolerance? So the value and tolerance, what are they asking? What is the color code for a certain resistor? So you're gonna do the colors. What is the value and tolerance of a resistor? Okay, so this is separate from the last one. So they're gonna give you colors, and then you have to give the number of ohms and the percentage. What is the value and tolerance of another one? So you're gonna get two of those. This one, I'll have to look at this one, 4 colors. What this one is, I remember, there are times when we use other than silver or gold.
20%.
And without, and if it doesn't have one, it's 20%. But sometimes we want to get a little tighter tolerance, we use a color. And this test will not ask you, if you know the colors, there's some that the colors don't match, where it's just not the standard 0, 1, 2, 3, 4, 5 when it comes to tolerance. But this one, all the ones we give you in here will be the color. So if this is a red, it's 2%. So it's not going to be anything. There's a couple that's like, if green is like 0.75 or they're odd, they don't match the color. So these are just straight colors. Okay, what are the possible minimum and maximum resistance value for the resistor in the previous question? So you'll just give me a range. So many ohms to so many ohms. So there's your typical. I still have, still having a few people having difficulty with this third one being black. Black is 0. The third band is the number of zeros. So if you have black, black is 0. That means 0 zeros. If it's brown, then you have a single 0. But I'm still getting people giving me a 0 to represent the black representing 0. What is the value and tolerance of a resistor color coded red, green, red, red? So there's an example of a 2%.
252.
You can write down the colors, but I've changed these. The only one I didn't change was that one that had the 12 zeros and the 1.
That's okay. As long as I know that.
So there's an example of a 4-band. Again, there's some colors that are off numbers, but you're not going to get one of those. Just put whatever the color is.
So that one.
So that would be, that one
Would be
there would
3%?
actually be, give an example. It's still going to be, as we usually do it, it's going to be 2, what's green again? 2500 plus or minus 2%.
Oh, red is 2?
Red's 2.
And show me that, don't,
I got it wrong?
I don't know.
don't give me 252 on the answer. I want 2500. That third color band is the number of zeros. This doesn't, I'm asking for the value of the resistor. That resistor is not 252 ohms.
Hold on a second.
So I'm getting a couple of those.
Wait a minute. Time out. I got my color code. Red is 2.
Yeah,
Damn it.
thank you.
You know what? I numbered them wrong again. It's all right. It's all in the.
I've been meaning to talk to you about that.
We're
See, here's the ones that I was talking about. Green is 0.5, blue, when you're talking tolerance. Violet is 0.1. Those are the, I won't be asking you those, any of these. So these are the standard ones, 5, 10, and no color. If it just has 3 bands, it's 20%.
The book, this one, it has them all changed now. It has them exactly the number of resistance. Yeah, it is. So. It has it, on the book it has it 6%, 7%, 8%.
Oh, for all of them?
Yeah.
Oh.
So that's not getting too bad. That's not getting
Okay, in your book?
Yeah.
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 There it goes.
So,
Blue is six.
you know, maybe the book.
So again, I'm only gonna ask you a value that is a direct. 3 is 3%, 4, 4%.
Yeah, because the book is selling it different. Like, green is not, green here is 5%.
Yeah.
Unless it's a typo.
Well, it wasn't a typo, somebody made an assumption when they were putting
Yeah.
that together.
And then it jumps to 0.25 and that's done.
Okay, so that's 2,500 ohms. That's the one we saw earlier. The 2, the 5, and the third band is the number of zeros. 2 resistors are connected in parallel. Both are so many watts. What's the resistance total? So this one is, you can do the 1 over x and get the resistance total, but when they're the same, with 2 resistors the same, you just cut them in half. If you have 2 resistors that are 10 ohms each and they're parallel, the resistance is 5 ohms. You can do that, and it doesn't always work if you have. It doesn't work if you have multiple resistors.
But just to.
Just 2. I think no, I'm not gonna say it. I was gonna think there was another alternative, but I could be wrong. I can't be certain. I'm not gonna speak it. 3 resistors are connected in parallel to a 9-volt line. Total current is 3 milliamps. Resistor 1 is so many ohms, and I guarantee you these are not the ones. I changed these. Resistance is another one. So what is the third? That's not difficult. So what you'll do is you've got the resistance, you've got the voltage, and you've got the resistance for 2 of them. You could just figure the current. They gave you the total current, so you can figure you've got the voltage. So with the voltage and the resistance, you can get the current for those 2, and then you subtract those 2 from your total current, and there's your one remaining missing current. Anyone have trouble with that? And I went over it quick. If you have, let me draw it because I want to be fair if you're not getting this.
Nick, you're not getting it? Nick, you're not getting it?
If you have 3, if you remember, a couple of times we had to get current. We had ohms for each of these. So we can take the voltage and the resistance and get amps. So what they're doing is they're giving us the resistance for 2 of them. So right away we can use the 9 volts, if it is 9 volts, and the resistance to get the current for each of those. They're giving us the total current. So all you have to do is, current is additive when it's parallel. So you just add the 2 currents and subtract it from the total, and that's your missing remaining current. Here's my example. So here in blue, I've highlighted, there's 15 ohm, 15,000 ohm, 25,000. They got 6 milliamps and 9 volts. So volts divided by current gives you resistance. Is that the way I wanted to go? I don't doubt there's volts divided by resistance gives you current. Yes, so yeah, you get volts divided by current. Okay. Oh, so what they're doing here is getting the total resistance and figuring it the other way. You can do it that way too. So they took, I liked my way better, the first way. This one gives you the first, all the resistance, you're figuring the total resistance, and then you're doing the x over 1 procedure backwards. So you can do it that way. You can do, the total resistance is 1,500 ohms. So you can do 1,500 ohms, 1 over x minus 15K minus 1 over x. You know, you just, it is hard. The first way that I showed you up here is easier.
Nice. No way.
This was so you have a couple ways. But this one's easier. Figure your two currents, figure your, the total current is given and subtracted. A circuit consists of 3 resistors connected in parallel, and they're different values. If the current flow through R2 is amps, what is the voltage across R3? Anyone? This one is actually quite simple. You're given, you don't even need any of this, most of this information. Resistor 3 is 15 ohms.
Yeah.
All right, let's see which one is it. One of these is going to give you voltage.
It's 2.
R2 equals 3 amps.
Yeah, there you go.
So you got R2 is 30 ohms, 3 amps. You get a voltage, right? It's parallel, so all the voltages are the same. So right here, R2, 3 amps.
This is fourth edition.
V3.
You got 3 amps and 30 ohms. You can get volts. It's parallel. Once you get the volts, they're all the same. Yes.
Point zero one. No, okay, great.
Yeah.
That's just one of red, right?
Just to clarify, right here, it's giving you, it's telling me R2 is 30 ohms. And it's also telling me that R2 is 3 amps.
Yeah.
Yeah.
So
So it's 90.
to get volts, I just measure, I multiply current times resistance.
90.
90?
30 times 3.
I'm after volts. Sorry, that was previous. So if I got, it's 90 volts, right, from here to here?
Yeah.
90 volts. What is it for the other two?
90 volts.
Yeah, it's the same. So this giving you R1 and R3 are just sending you off on a wild goose chase. Get the total volts for R2, voltage drop is the same in parallel circuit. Okay, 48 volt source is required to furnish 192 watts to a parallel circuit consisting of 4 resistors of equal value. What is the value of the resistor? One of the easiest way to do this for me is you can take the voltage and the watts and get total resistance. You can, once with that total resistance, you can do total resistance x over 1 equals and get a decimal and divide by 4. And then convert it, and then do x over 1 equals. And then once you get it, you can double check your work because whatever resistance to it, 1 over x plus 1 over x plus 1 over x plus 1 over x, and see if you get your original voltage. If I lost you on that one more time, take your voltage and your watts and get total resistance. It's a parallel circuit, so resistance is that 1 over x. You're working it. See, when we get all the resistance, we do 1 over x, 1 over x, 1 over x, and that gives us the answer. We can do it opposite. We can take the answer first, the total resistance. 1 over x gives us a decimal. Divide by 4 the number of resistors, and then 1 over x to convert that 1/4 back into the total resistance, back into that total resistance value. And then double check your work.
Can you explain it one more time?
Yes. Okay, right here, I'm going to make up numbers, so I'm just going to do the procedure. Suppose, here it is, 4 resistors. They're equal value. I can take my 48 volts and 192 watts and get a resistance total.
Divided by 4.
If I go into my scientific calculator and punch in, suppose it's, I'm just going to say 350 ohms, just for the sake of the process. I take my scientific calculator, I punch 350, and then I do 1 over x equals, and I'm going to get a decimal, point something, 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 something. Now I divide that decimal by 4. Yeah, and it's going to give me a decimal answer.
So 1400 each resistor.
and then I do 1 over x again equals, and it's gonna invert it back to resistance. So I'll get a number that's much smaller. No, these actually the resistor will be
They're gonna
bigger.
be bigger, yeah.
And then whenever you get whatever you get there, double check it. Just take that new resistor, that new value, and do 1 over x plus 1 over x plus 1 over x plus 1 over x, and see if you come up with your original resistance total.
So would it be 1400 for each resistor?
Yeah.
You know, I was just pulling numbers out of my
No,
backside.
but 350, 350 with the x1 times 4, and then x1 again. I got 14
1400?
for each resistor.
14K, 1400, 1400. So
Uh,
then, if you do get 1400, now do 1400 plus x over 1, 1400, 1 over x.
Oh,
1400,
so go
1 over
back
x.
and double
So
check.
go backwards again and make sure that you come up with your original, and that way you know it worked.
Which I get 350.
Okay, so that's how you verify your work.
That's a good way to do it.
Okay, you have a parallel circuit with 3 resistors. A 10, a 20, and a 40 in this example. You measure 25 volts across the 40 ohm resistor. What's the current flow through the 10 ohm resistor? Okay, it's a parallel. So if you have 24 volts across the 40 ohm resistor, you've got 25 volts across all of them. So you take your 25 volts with your 10 ohms resistor, and you get your figure your current.
Yeah, so you go.
That's the only trick to this, is remembering they're throwing you by giving you the voltage on another resistor to make you think, okay, all the resistors have the same voltage.
0.62 or 0.625.
You have a series parallel circuit. 2 resistors are in series with a parallel leg containing 3 resistors of equal value. In the series resistor are both 125 ohms, and the total resistance of the parallel leg is 45 ohms. What is the circuit total resistance? Okay, the parallel leg, they're already giving you the total.
So is that where you do x1?
So you just add them together.
Oh.
2 resistors are in series with a parallel leg containing 3 resistors, but they've already given you the total resistance of the 3 resistors in parallel. So the series resistors are both 125, so it's 125 plus 125 plus 45. Those are not the numbers you'll see, but that's how that works.
So they threw you out for the three resistors.
Yeah, the 3 parallel, right?
They threw you out.
Yes, it throws you off. You could figure it. They could say the 3 resistors are all of them. They could give you the values, but they've basically saved you the trouble by just doing the parallel resistance for you. So it's a series, essentially, just add them all. Then you'll have one of these, and I have some samples of this to do after we're done here. The key to this one is these 2 currents. Anyone still having trouble with this?
R2 and R3 are the same on the on the
So yes, R3 and R5 are gonna have the same current.
R5 and R4 and R5
It's in series. R4 and R5, R3, 4, and 5 are all
are
gonna have
all
the same current.
But R2 and R3 are going to have the same current as well, correct?
No.
R6.
R1 and R6.
Can you do the same thing?
You have to add them together.
You have to add R3, R4. No, because remember how we had the current, the initial current for the first one was the same as R2.
No, it
No,
was not.
come again.
Okay, so you have your voltage. Then you come into R1 right here by itself.
Yep.
then it splits. You have one resistor over here, now you have 3 here. Whether it's a mess, I know. So here's 1, 2, 3, 4, 5, 6.
Just one that we did yesterday, and you said break it down 3 times, redraw it 3 times.
Yeah, I think it only had 2 resistors. I'm not sure. I don't know if there were 3 in here. So you got all your current. You understand where your current is. You got the current over here. In this example, well, it's
actually.
you get R2, you have current, and R3, you have current. R4.
So you have your total current.
So that's your total current. You have one river that splits and comes back together, and all you have to do is add the 2 splits together.
Oh.
So right away, you have the current for R2 is given, R4 is given, and R3 and 5 are the same because they're in series to each other. 1 and 6 are all by themselves, so all the current flows through them, and your total current. So right off the bat, you have all the currents. So you'll have the current and volts almost immediately off current and volts for R1. You'll have only the current for R2, but you'll have milliwatts and current for R3. Only current here. You'll have volts and milliwatts,
Yeah.
milliamps, and then you have total current in volts and milliwatts in total current. So you're going to have like 80% or so of your two values in each line.
So I was gonna ask about the nodes in connection. Isn't it like it's only a series and parallel if the resistors are connected to the same node, right? If they're connected to the nodes, right?
These. I'm trying to think of.
Because what I'm getting at is that it's unrelated to this kind of problem, but what I was trying to get at was like I've seen a circuit or a mesh where there would be a resistor and a line connected, but not by a node, just there. But it was in the circuit. So you'd have to do that one separately.
I'd have to see it.
Yeah, because I was confused too. I was like, but because I read it only if they connect to a node together are they in circuit together. But I've seen one where there was no node, and then over here these 2 were nodes, and you had to do this and that.
You'll see lines that cross each other, and if they don't draw a dot, they're not touching.
Right.
Normally, we draw this. How we draw? We draw a little hump over it, and that's supposed to indicate that it jumps over. But I always question it when there's no little dot and they cross each other. You have to assume. Well, then I start looking around, and if they've got dots in other locations, then it looks like. But most of the time, you'll see a little bridge.
And I think I've seen an H where the third resistor, it was in the center but not connected to node.
If it doesn't go anywhere else.
Yeah.
I mean, if it's a T and it runs up to that T,
Right.
and then I would assume that it's a connection. So
This is the August 1st test.
yeah, this is the number 3. So if we do it on the 1st, or that's what I had the calendar back there.
So we have 3 tests in the final,
We have 2 more tests in this class.
and then a final.
This and the final. I have some samples of this. We'll do this a few times.
This in the final.
What is the point of a Darson ball type galvanometer attached to? I can't remember if we talked about this in the lecture yet, but it will come. It's just asking what the needle is attached to. And we'll cover it in the lecture, but it's attached to a little magnetic coil.
It's proportional to amount of current from the coil. Deflects off of that.
Yeah, you've got your needle's up here, and it's attached to a little magnetic coil. And then the voltage goes into it, your DC voltage goes through it. And then on the outside are permanent magnets with a positive, negative field. And there's also a spring in here that draws that needle back and parks it to the left. So as you increase the measurement, the voltage you're measuring, it goes, very small amount of it is tapped off, and we'll talk about shunt resistors. Very small percentage goes to that electromagnetic coil. So the more measurement, the more we're reading, the greater the magnetic force is in this little coil, and it wants to align with these permanent magnets out here. And it's fighting that spring. So it's a balance between the amount of current we put through it and that spring pressure. So the answer to this question is a small pivoting coil of wire in a field of a permanent magnet. Yeah, I should have just turned that one up. There it is. I didn't have to draw it.
What is it
We'll go over
attached
this
to?
Yeah, we'll look at this a couple
Pivoting
times.
coil.
So does that coil just retain its strength its whole life, or is there like?
Well, you know, it's not. I would be more concerned about the permanent magnets because the coil won't degrade, and it gets such a small amount of voltage. I think it takes like 1/10 of an amp or something to move this. It's a very small amount of
Or it
current.
could be designed to take this 1 milliamp here to 50 resistance, whatever it's setting.
Well, see, that needle swings full scale. So the amount we adjust through the selectors, what is allowed in there. But it's this coil doesn't change, so it's always going to be the same amount of current that's going to give you full scale deflection. I don't care what you're measuring. You get full scale, you're going to have the same amount of voltage, and I think it's, in most cases, it's 1/10 of an amp or 100th of an amp. I think it's 1/10 of an amp. It's a very small amount. It'll always be. I don't care if you're measuring ohms, amps, volts. If this needle is sitting on full scale, you have the same amount of current going to that coil every single time, because that's what it takes to put pressure against that spring and align with these. So as we make rotary selections, we're fine-tuning what and how that current goes to that electromagnet.
Is that through the different springs? Is that what you're saying?
It's the same spring.
Oh, okay.
It's just that when the voltage, see the red current coming in?
Yeah.
As we make rotary selectors, if I'm going to measure a 1.5 volt battery, I'm going to make selections on the meter that are going to open up a greater path. If I'm going to measure 1,000 volts, then I'm going to make selections on the meter that are going to really taper it down so I'm not hitting this with 1,000 volts. It's going to restrict it, increase the resistance. So whatever goes through these red coils will always be the same, because all you have is magnets, a spring, and a coil, no matter what you're measuring. So it's the selectors that we make on the meter that determine what goes in, how much.
Do you have a
How much we're supposed to
do you have one you can take apart?
Don't think so, but I can very easily pull up Google Images and show you one that's apart. That's why you see if it slams hard, that's because you've got the wrong selection and you're letting more current in there than you should be.
So if we had a shunt resistor while we're using, when it's between slamming, it would stop that?
Yeah, but the meter has shunt resistors inside already. So that's what you're doing when you're making selections, is you're rotating through various types of shunt resistors. We're gonna see that. I think it's in part of the description today or my presentation. So describe the basic operation of a D'Arsonval type galvanometer. And that's what this is. This is the galvanometer. Electric current passing through the coil tends to turn its direction parallel to the lines of induction. The amount of travel is dependent on the strength of the current. You can say the current flowing through a coil balances against a spring. You can, however you want, as long as you have a general idea of how it works. I'm going to talk about this more later.
Can we say like the interaction between magnetic field created by current?
Yeah, I mean you've got a floating needle attached to an electromagnet that is aligning with a permanent magnet against a spring. That's also basically what's going on.
And then the amounts are
If
current
you
would
do-
obviously
I've got-
dictate.
And that's the last
swing
question.
events.
So it asks a couple questions about the galvanometer. You got one of those. You got a couple word problems asking you. And those were all fairly simple as long as you sit down and think about what they're asking.
They're gonna be presented as word problems.
These are them.
Yeah.
These are right out of the test, but I've changed the values, the numbers. Okay, it's 5:20.
So what's the date?
Well, that's what I wanted you to see
I
that.
think we're,
You may want more time.
about next week.
So today is the 20th. We could do it a week from today, or we could do it the Monday after that. It would be my recommendation. I don't know that you want to get.
Tuesday
vote.
after.
Tuesday. Well, we have the weekend to study for first.
Yeah, but I'm not gonna study. I'll be honest.
All right, everybody, let's vote.
Just take it now.
Same.
Okay.
How about we give an answer on the 25th?
Yeah, I agree. Give him an answer.
I think we could do it,
I think we do it Thursday.
I think we can do it on the 25th.
I mean, how can it be any different than what we just
Do you really want the pressure of like studying on the
I don't wanna
weekend?
study it.
It's like kids.
Who wants the 27th, raise your
I
hand.
don't agree with that.
Man, honestly, I could see.
I'm not doing it on the 27th.
Where's right now?
Okay, it's the first.
Just like half schedule.
It's the first.
August first.
The only I was trying to give you the options because we have, I wanted to give a little buffer if you wanted it to last day. Okay, so we'll keep it to the schedule. It'll be on the first. And the written number 3 is due.
I'm gonna forget
So-
everything we just talked about.
I'm still missing some written 1s and 2s, which is a parallel circuit and a series circuit drawn. They're not that tough.
I got it.
And then written number 3 is a paragraph or two. Try to give me close to half a page.
What is that talking about?